This is AS Maths Pure. We're looking at Unit 1 notes, and this is 1.4, then magnitude and direction of vectors. So the magnitude of vector is obtained by the Pythagoras theorem. So if you look back, just even kind of some of those previous ones that we had, let me see. For example, this vector here, or vector A, is 1, 3. The magnitude is simply the length of that line as we work it out. So if we set it up by Pythagoras, be 1 squared plus 3 squared would give us then this squared, and that's all we're doing here. So let's take a look back and see what we have. So the magnitude of OA, which can be written then as OA with our two lines, this means the magnitude. Also our two lines here means magnitude of A, 1 squared plus 3 squared, that gives me 1 plus 9, so it's root 10. OB, you remember then, was 2, 1 as well, so it was 2 squared plus 1 squared, root 5, and then AB was minus 1, 2 squared. Again, you can take a look back at the previous page if you wish, and that then is root 5 as well. So in general, R is equal to xi plus yj, or xy. Then the magnitude of R is using Pythagoras then for that. So magnitude or length then is the square root of x squared plus y squared. The direction of the vector is found using trigonometry. So again, if we want the direction that this one's going from here to here, that would be our x, that would be our y, and we would just use our tan theta then as over A. It's much easier if you just look at it as an example. I would have thought, so let's look at example 1 and see if we can work out what's going on. Find the magnitude and direction of the vector minus 7i minus 4j. So minus 7i would take us that direction there, use a squiggly line, and then minus 4 there. So we're actually going to have 7 is the length of that, and 4 is the length of that. That's a wee right angle. That's going to be the distance we're looking for. Let's call it A. And we're looking then for this angle here. That's going to give us our direction. So we're letting A equal minus 7i minus 4j. That means then our magnitude of A, again we write it with our two wee lines going down here, is equal to the square root of minus 7 squared plus minus 4 squared. 7, remember of course that's a positive, 49 plus 16, and the square root then of 65, and we're happy enough then just to leave it like that. However, if you want to go then the three significant figures would be 8.06. To work out then our direction, that would be our opposite, that would be our adjacent. So O over A, tan theta is 4 over 7. Put it into your calculator. Theta is tan to the minus 1. 4 over 7. And theta then is 29.7 degrees. Again, I've given that to three significant figures. Therefore, our magnitude is 8.06, and then it's acting at 29.7 degrees below the negative horizontal. Example 2, the magnitude and direction of the vector are 13 and 22.62 degrees below the positive horizontal. Find the vector in component form. So this was pretty much this question backwards. So we know it's going at 22.62 degrees below the horizontal. That's my horizontal there. So that's 22.62, and we know then that is 13. So we have to set this up then. So that's going to be our H, or OA and H. That's our O, and that's our A. So if we have, sine theta is O over H, sine 22.62 is O over 13, O is 13 sine 22.62, and O is pretty much 5.00 to 3 significant figures. Cos theta is A over H. Cos 22.62 is A over 13. A then is 13 cos 22.62, and A then is 12.0. That means the vector must be 12i plus 5j.